Okay, so we will begin our exploration of the hardware side of the digital input by first trying to show you the concept of a floating input. So I'm going to start with a jumper wire, and I'm putting it into pin number 2. And then I will carefully insert it over here into the breadboard just so the other end isn't floating around, shorting against things when we plug the board in. So we have an input that basically goes nowhere electronically. I'm going to plug the board in like so, just so we can start to program it. And now, when we did our LED circuit as an output, it was easy to tell what was happening because we were controlling the output. We were turning the light on and the light off, and we physically saw a light in the real world telling us what was happening. But for input, we have the opposite situation. We're going to be touching a switch in the real world, and we want the computer to tell us when it's on and when it's off. So we need some way for the Arduino to communicate back to our host computer while the program is running. And that, of course, is going to be through the serial monitor. Remember, I told you that one of the things the serial monitor can be used for is to pull information off of the Arduino while the program is running. So we're going to start with our two favorite functions, void setup, and you should know all this by rote now, and void loop. My voids, my setup, my loop all turned orange, which means I typed everything correctly. So the first thing we're going to do is what we did before for our hardware configuration. We're going to do a constant integer, and because we're eventually going to use this to create a button plugged into the Arduino, I'm going to call the variable I'm creating button. And I'm going to assign it to my pin number 2. So now I need to talk to the serial monitor from the program itself. And I use a special set of commands that all begin with the word serial in capital, and then a period or dot character, and then the method or function of the serial port object that I want to call. So in this case, we're going to start with the begin function or method, and it needs an argument in parentheses. So the argument we give it in parentheses is the baud rate, the communication rate we want the Arduino to be talking back to the computer at. And it's going to match the baud rate of the serial port. When we see the serial port open up later on, we can select baud rates in there. Bauds are just characters per second. So we're telling the Arduino that it's going to send information at 9,600 characters per second, and that's going to have to match the software serial monitor in the Arduino authoring environment, which will also be set to 9600. So that line just turns on serial communication. And then down in the loop, here's all we're going to do for a very quick test. We're going to say serial.println. ln means line, which means at the end of this print command, it's going to put a new line or carriage return. And then something inside parentheses. So that's just going to print a character to the serial port, or print some information to the serial port. What are we going to print? Well, we're actually going to call another function inside the println function, and it's going to be, instead of a digital write that we use for turning the LED on and off, it's going to be a digital read. And it's going to have parentheses like so. And what are we going to digitally read? We're going to digitally read button. So serial.println, what am I going to print? A call to digital read button. That call is going to return a value, in this case an integer, and that integer value is then going to get printed to the serial port so we can see it. And anytime we're doing things with humans and computers mixed together, we usually put a delay in there. So our delay this time is going to be about 100 milliseconds, tenth of a second. Seems to work out well for this application. So the board is plugged in, the wire is hanging out there going nowhere. Remember, this connection is not actually connected electrically to anything of meaning. In fact, it's not even connected to ground. It's just floating, quote unquote, electronically out in the middle of nowhere. So let's go ahead and upload. So far so good. We'll hit the serial monitor. And notice at the bottom, first of all, here's our 9600 baud that matched the serial.begin statement. And we're getting a pretty consistent good string of zeros. But if I reach out and touch, let's see if I can do anything here. It's actually fairly well grounded. You see those little ones that go by? So notice as I'm interacting with the circuit, I'm getting ones. Where are they coming from? It's actually the capacitance in my body is affecting that floating circuit. If I unplug it from the board, it actually will float even more. I just want to be very careful to hold on to it so that bare end doesn't touch anything on the Arduino. So there is the floating value. Because there's no finished electrical circuit, that input is just picking up stray random voltages and converting them into ones and zeros as it interacts with this crazy environment where things aren't electrically defined. So how do we fix it? The only way to fix it is in hardware. So I'm going to unplug and we're going to put in our button. So I'll take the wire out for now just to get a clean working area. And here is our super tiny button switch. I think I've actually probably bent these legs slightly flat so they fit into the holes better. We're going to put it above and below the trough, and notice that it's too short to go this way. So there's only one 90-degree orientation where it works and reaches across the trough, and that's the right one, of course, for it to work correctly. So I put it in, I plug it in like so. So the first thing to know, I'll use the wire as a pointer here, is that this point right here is now electrically connected to all these points directly below it in the column. This point above is electrically connected to all these points in the column, and because the switch is here, this point is actually connected to this point. So there's a built-in connection in the switch, top to bottom, that goes across the trough. So all of these are the same as all of these below, but they have nothing to do with these over here. So this column here and this column here are connected one to another through this side of the switch, but there's no connection from this side to this side until we hit the button. When we hit the button, we make a momentary electrical connection from the left side of the switch to the right, or the right to the left, however you want to look at it. So now let's put back in our signal wire. So we'll go back into pin number 2. And we'll come over here and we'll go into the right-hand position at the top. So now we're connected to the right side of the switch all the way through. And if we look back at our circuit diagram, you'll see the signal cable, and it connects to one side of the switch. And then on that same point electrically, which means anywhere in this right-hand column, top or bottom, we need to make a connection through a resistor to ground. And the purpose of that resistor is to ensure that there is always a connection to ground, which means with nothing else going on, our circuit is always going to show a 0, a grounded state. And here is our pull-down resistor. We call it pull-down because it's pulling the value down to 0 or down to ground. And this one is brown, black, and orange, which is a 10 kilo ohm. So it's a very high resistive value. And I can plug it in anywhere in this column and then down to the ground bus down below, like so. So this is a path of very high resistance. It goes from ground through the resistor, through the open switch, because the switch does not have to be pushed for this connection to happen, through the signal wire to pin 2. Pin 2 would love to go any other path it could possibly find, but that is currently the only path available to it. So it's going to take the path of least resistance, which in this case is a path with a lot of resistance. But we're going to change that in a moment. So when we push the button, we'll normally be seeing a 0 state, but when we push, we want to see a 1. Well, how do we create a 1? A 1 is 5 volts. So what we're going to do is we're going to take this red cable and we'll plug it into the top to our 5-volt connection, and we'll plug it in to the left side of the switch, anywhere in that column, up and down. So now, in the open state of the switch, when the switch is not pressed, the path of least resistance is the wire through the switch, through the resistor to ground, and we see a 0. When we press the button, the path of least resistance, so here we have a huge resistor, and here we have just a switch going across through a wire. There's no resistance here whatsoever. That path is going to be wire into the switch, and when it's pushed across the switch, up this column to the red wire to 5 volts. So you can think of it from the standpoint of the input. The input either sees 0, because we go through the right-hand path to ground, or if we push the button, it goes through the left-hand path to 5 volts. And then as a double check, we want to make sure, has this circuit we've created have any possibility of a short circuit? That is a direct connection between power and ground. So here's our power bus. It comes in here. The only way it can get down to the ground is through the switch and through, guess what, this very large resistor. So the resistor is there, in part, to keep there from being a direct connection between the ground and the 5-volt bus. All right, let's plug it in and see what we get. So we're going to run exactly the same code for now. And I will actually close the window so we can see the code again. So constant integer button is assigned 2. In setup, we do serial.begin at 9600 baud. And then in the loop, we serial port print line a read of the button and then delay for 100 seconds before we do it again in an infinite loop. So I'll upload it again just for fun. And then we'll run it with the serial monitor. There it goes. I could probably move this over a little bit so it's not buried in the corner there. So we're seeing the 0 because of this path down through the switch to ground through the resistor. And when I press the button, a nice reliable 1. And when I release, 0 again. Notice I'm touching the resistor, I'm getting nothing. I'm touching the wires, always 0. Because now my body with its capacitance is offering way more resistance out here in the open air than this 10K resistor. So this is always the path of least resistance until there's an even better one through the switch to power. And that is how we handle a digital input. I'll go ahead and make a couple little changes to the program while we're looking at it, just to do it a bit more like the way we would actually do it. We are just printing out the read of the button, but in a typical program, you're going to want to do something with that information. So instead of just calling the function here and then not having its value later on down in the program or in another subfunction or whatever, we want to store it. So right at the top, after we did our constant integer button, we're going to do a new type of variable, which is the type that actually varies. So instead of constant integer, we're going to type just integer. And then I'm going to call it button value. And I can assign it an initial value of 0. But this is going to be the type of variable that can actually vary. It can change. And then down here, instead of printing a read of the button, we're first going to do this. We're going to make a new command right before it. And we're going to say button value, our new variable, is assigned, and it's going to be assigned what we were printing before, which is this call to the function that reads the button. So I'll cut that out. I'll put it right here, and I'll put a semicolon at the end to make it a complete statement. So we are going to read the button, create a value from that, and then we're going to assign the value that we read to our variable button value. And then in the print statement, we're going to print, guess what? The variable. So each time through, we read the button, we print the button value, and then we delay. Now we could add in a bunch of other things, that if the button was pressed, do this, and if they haven't pressed it, or if they press it this many times within a second, so that's a double click type press, do something else. All sorts of different things can happen once we store the actual variable value. All right, let's recompile that just to check and make sure I got everything right. So far, so good. There's our ones. All right, minor change, but it gets us closer to the type of programs you're really going to write in real life. So we saw digital input, so logically the next thing we're going to take a look at in our next video is an analog input.